hear me fine? Okay, cool. My name is Pradeep, and it's been an amazing 2 days in Wellington so far. The weekend has been great. Love always being here. I also have the unenviable pleasure of standing between you and your lunch. Some amazing lunch out there. So I'll try and keep it as short and quick as possible. This conversation is more about ideas rather than a product or a specific bunch of tool sets. So what we're talking about today is data mesh architectures, and primarily from an agenda perspective, we'll be talking through what does data transformation mean? We're all going through a huge amount of digital transformation, but what does it mean from a data transformation perspective? We'll be talking about data mesh and its primary principles. We'll be looking at the concept of data products, and then we'll be looking at data mesh platforms and what it means from a data science perspective. Okay, so a lot of organizations globally are going through a digital transformation process, and this digital transformation has produced a lot of goodies in terms of, let's take process as an example. We talked about agile, we talked about extreme programming, we talked about a lot of these factors wherein teams are much more independent. In terms of technology, we've had transformation in terms of organizations being much more cloud native, organizations using much more distributed technologies, containerization platforms, container orchestration systems such as Kubernetes, and there's a lot of stuff which happens on the digital transformation front. But what does it mean from a data perspective? With all of this transformation, how does data architecture look in a lot of organizations? When we talk about data transformation, this is how I try to look at data transformation. For me, data transformation is primarily in terms of extracting value from the data that an organization has. And I look at it from both a data offense perspective and a data defense perspective. And even though organizations are going through a huge amount of digital transformation, there's a lot of emphasis even now on defense aspects, which is primarily around data quality, data loss prevention, and a lot of these factors which organizations focus on heavily. But then in terms of transformations, organizations need to start focusing more on offense capabilities, just primarily about using predictive analytics, which is about being prescriptive analytics as an example, which is about using AI and ML. But it's not so easy moving from your data defense capabilities to upgrading to a data offense capabilities. And if it is so easy, a lot of organizations should have been on the left side of this chart yesterday, right? Because everybody wants to do AI, ML, everybody wants to do data science. But moving up this curve is it's really, really hard. And the primary reason why it's hard is primarily because of how data architectures currently look. Most of the data architectures currently primarily tend to focus on multiple areas. So generally, data architectures across organizations tend to have an operational data plane, and this is an area where you tend to have your microservices, you tend to have your systems, applications, front-end applications, and a lot of others. In this area, you primarily focus on small-scale data. You primarily focus on data which focuses heavily on asset properties. You primarily focus on domain-related data. And this is where there has been a lot more transformation happening. And post this, you tend to have a bunch of pipelines, and these pipelines primarily are responsible for pulling this data out from your operational data systems into the backend. And we'll take a look at the backend. And these pipelines primarily focus on ensuring that they can move data across, but they also focus on adding value into this data in terms of maybe summarizing this data, cleaning up this data, looking at data quality. And where do they move this data to? They primarily move it into the analytical data plane. And this is where we try to derive value from the data that we have. And in the analytical data plane, we primarily tend to focus data in the large. Here we're looking at gathering intelligence from data. And one of the primary parts of transformation is not just technology, but also organization cultures. And this sort of a culture heavily makes sure that while in the front end, teams are organized in terms of domains where they're focused on business areas and transforming businesses, but on the data plane, they're primarily focused on functional teams, where it's much more about technology. There might be a bunch of DBAs organized into a team. There might be a bunch of folks who specialize in a particular technology being organized into a specific bunch of teams. So there is a lot of discrepancy between how teams, culture, and technologies operate in the operational data plane versus the same sort of things in the analytical data plane. And if you want to transform your data or your data architectures, this is definitely not helpful. The primary challenges from this sort of an architecture, it's primarily monolithic in nature. A lot of organizations tend to have data lakes, delta lakes, data warehouses, or whatever you call it, but it's still one large monolithic system which manages all your analytical needs. The teams are heavily focused on being functional in nature rather than being focused on the business needs of the organizations. They tend to be much more technology-oriented, and it's very hard for these teams to sort of even connect to somebody on the front end. So for example, there might be a particular field in a table, and by the time it comes down into the analytical data plane, for somebody who's a data analyst to even make sense of what that data means from a business context, it becomes very hard because data loses context as it moves down from an operational plane right up to your analytical data plane. The other parts of it is latency. A lot of organizations, even now, take 8 to 10 hours to produce certain management reports, which take a lot of grunt work to prepare. And that's definitely not helpful when we're talking about real-time insights. So these are primarily issues that we have in terms of technical challenges, but it's also the culture aspects of it, wherein the way you treat people in terms of how they look at business problems is very different from the operational data plane into the analytical data plane. So we'll look at there are various ways in which organizations try to work through this. And there is no one way which fits all organizations. And the idea that I'm talking to today is a data mesh architecture idea. And this is one of the ways in which you can help transform data architectures. So primarily, data mesh architectures primarily focuses on empowering organizations to turn the data landscape into platforms. We had others talk about platforms in the morning. We had a bunch of good conversations about platforms in the morning, and I'm sure you guys had a lot of good knowledge coming out of that. So primarily, data mesh talks about enabling platforms within your organizations, and these platforms primarily focus on data. And it's about ensuring that data is democratized and decentralized rather than sitting in a monolithic system, and ensuring that people have access to this decentralized and democratized data. It's about ensuring that there is scalability and agility purely because now you don't have data sitting in one large blob, but rather being distributed across your whole organization. So that's the primary idea of a data mesh, and that's what we're going to look at in the next 20 minutes. So data mesh primarily works through a bunch of principles. The first principle is the concept of domain-oriented ownership. The concept of domain teams isn't anything new. Domain teams have existed for quite some time now. Domain-driven design is an example wherein organizations imbibed a lot on how to design their systems. We've also had the inverse Conway maneuver, wherein you want organizations to set up teams based on how they want the architecture to look like. And that's where this idea comes from. So domain teams no longer just own their applications and their systems, but they also own their data. And it's not about just creating these systems and applications and pushing data down into an analytical data plane to disappear somewhere else and for somebody else to worry about it, right? That's a primary concept of domain-oriented ownership. This also ensures that there is decentralization and democratization of data. Data need not go into one single central place to be managed by one single large team. So that's the first principle. The second one is data as a product. This is one of the core principles of a data mesh, wherein we are treating data as a first-class citizen rather than a byproduct of the applications and processes that generate this data. And a concept of a data as a product is that it is an architectural entity which can be designed, developed independently by a team, and its whole life cycle can be managed by this domain-oriented team. And that team is responsible for the overall life cycle of it, and they take care of the whole data product. The third one is about federated governance. So primarily what we're talking about is how do you ensure governance across in this decentralized world. Managing governance in a monolithic system is hard, but managing governance in a decentralized system is even more harder because right now your data is not sitting in one place, but rather your data has been decentralized into multiple teams. And that's the reason why the concept of federated computational governance is key, because you're looking at things like policy as code. We're not looking at creating Word documents or Confluence pages which talk about your governance structures, but rather we're talking about using technology to enforce governance or create these governance structures in place, right? We're talking about using policy as a code, policy as code as an example to enforce computational governance. The fourth principle is self-serve data infrastructure. Again, this is not new. This has existed for quite some time. It's infrastructure as code, wherein we're not just creating these domain teams, but we're also empowering them to create the necessary infrastructure to manage their own data and to create their own data products. Now, we're talking about polyglot architectures wherein teams can figure out what tech stack works better to solve a particular problem. You're not being prescriptive about you have to use this tech stack, and not everything is a hammer, and not every problem is a nail for you to go ahead and use a single set of tools. And that's what we're looking at over here to ensure that we're empowering teams to use their own tech stacks and empowering them to use a self-serve data platform. Now, these principles aren't just standalone principles. They are highly related. The concept of a domain-oriented ownership, one of the issues with the concept of domain-oriented ownership is that now that we have decentralized teams and we are ensuring that they own data, there is a problem with the fact that they might end up in domain data silos, wherein these teams might then hold on to this data, and the way they expose this data would become much more harder. And that is the reason why with the concept of data products, the key aspect of a data product is that it has to be interoperable in nature. And that's one of the biggest priorities that we have in terms of creating a data product. We're not sharing data in terms of tables, views, or any other formats, but rather the whole idea is to share data in the form of a data product. We will try and understand more in terms of what a data product is, but a data product is a key cornerstone of this whole architecture. The concept of federated computational governance, again, now that ensures that the domain teams have the necessary power to create the sort of governance systems that they need and that they need to manage. And you also have the concept of consistency in the sense, now that you have self-serve infrastructure, you want to make sure the teams are empowered to create the sort of architectures that they need and the sort of design that they need. And that's the reason why you get these principles working in tandem with each other. And the last one is the fact that you need to enable discovery of data products. You need this to be socialized across the whole organizations. You need to enable discoverability, you need to enable documentation, and that's where data products come into play in terms of ensuring that all these principles work together to create a data mesh architecture. So what's a data product? A data product is a whole cornerstone of what is data mesh architectures. A data product ensures that you can share data in a reliable and consistent manner, and the whole organization has a standard approach to how they deal with data. So a data product primarily is autonomous in nature. This is something that is created by a single team, it's completely managed by a single team, and its whole life cycle is managed by that particular team. And that team is not just responsible for creating the data product, they're also responsible to ensuring that this data product is discoverable, which means that there have to be discovery mechanisms which have been built in. This data product is highly reusable in nature and highly interoperable in nature, and that this data product has well-defined interfaces which others can use. We all are used to using SQL or CSV files and a lot of other mechanisms to change. Even now, when I work with some financial institutions and I ask them as to how do I integrate with you folks, one of the primary mechanisms that comes through is to download a CSV file, right? Which happens in a batch mechanism, which takes ages. And that's what we're talking about here. Even a CSV file is fine, but we're talking about the ability to manage this as a wholesome data product rather than an extract from a table. These data products also ensure that there is autonomous management because the team which built the system is also responsible for managing these data products. They're responsible for managing the infrastructure, they're responsible for managing the lifecycle, and they're responsible for ensuring that it's documented and its interfaces are designed in such a way that it's highly interoperable in nature. And these data products are highly scalable because these are independent pieces of code. You can scale them horizontally. Unlike the previous architecture that I showed about, where you have data in a huge monolith, each of these data products can be scaled independently, and they provide horizontal scalability. So you can have as many instances of these data products as you need. And with serverless architectures, you can even scale them up. We did hear about serverless architectures yesterday. With serverless architectures in place, when the data products come in play, you can scale up these data products, and you can scale them down when you're no longer using them. So we'll look at what does the data product look like. When I was drawing this, somebody told me it looks more like an alien crab. But anyway, so in my view, this is how a data product looks like. It has primarily 4 specific areas. The first one is the input layer. These data products can get a variety of inputs from various sources, And these can again be defined by the team which defines a data product. These inputs could be, for example, an API to which it's listening in. It could be a REST API or a gRPC API. It could be a SQL connection to a SQL database. It could be listening into events from an event stream, or it could be actually reaching into a file store to read CSV files as an example, right? So this is the input part of a data product. The data product then takes this data and does some processing on it. And this processing could be anything. It could be summarizing it, it could be aggregating it, or it could even be creating future sets and training a machine learning model out of it. So we don't care what happens in the data processing layer. It's up to the team to figure out what they do with this input data. And that is the data processing layer of a data product. Post this is the output layer. Once the data product has ingested this data, processed it, it then defines a bunch of standard interfaces from which it can output data. And again, this could be multiple formats. As I said, it could be APIs, it could be event streams, or it could even be a machine learning model as a pickle file, as an example, which has been uploaded into a blob store, right? So those are three primary areas, but the most important area of our data product is its control layer. And this control layer is what allows things like discoverability, documentation, and a bunch of other factors. And this is what we'll further look at in terms of how do you standardize these parts of it. And the fact that the control layer also enforces security and federated computational governance, that's where these aspects come into play. But the most important criteria for data product is the fact that we are right now pulled data from a monolithic system which sat in a data lake or a data warehouse and distributed it and decentralized it across multiple teams. And we have set in a federated computational governance system. We have allowed these teams to sort of self-serve their own data infrastructure. This data infrastructure could be something like your Kafka, it could be SQL databases, it could be a MongoDB instance as an example, so that the teams have been completely empowered to create their own data products. But more importantly, the teams can now make sure that the data products are interoperable and they can talk to each other. In an e-commerce example of an e-commerce domain, you could have, for example, the customer team creating customer segmentation, such as bibliophiles as an example. If you're doing like an Amazon bookstore, you could have the cart being exposed as a data product. You could have a marketing team exposing campaigns as a data product. You could have the cart team exposing saved carts as an abandoned carts as an example, right? So you're not talking about teams reaching into SQL databases or file stores to access data, but rather we're talking about standardized objects with standardized interfaces to access this data, which have been well documented across well-defined interfaces. Now, a data product isn't an imaginary animal, but a data product can actually be created. Kubernetes is an example of an orchestration platform, and this is an example of a CRD instance that I created to sort of say, this is what a data product would look like in a Kubernetes environment. You are defining a bunch of input ports, you're defining a bunch of output ports, you're defining standard interfaces for this, and you can actually go and do a kubectl apply of this and have a pipeline to deliver a data product in a Kubernetes instance, as an example, right? This data product is primarily one instance, and you would need another set of infrastructure to ensure that you can deliver this data product across. It's just a definition as an example. You would need the transformation aspects of it. You would need CI/CD pipelines. You would need to ensure that you have the necessary compute to run it and the data storage for it to access data and process it. And that's what we will look at next in terms of a platform. Miro did an amazing session in terms of how critical a platform is to transform organization, how critical platforms are in terms of ensuring that you have the necessary culture, because innovation just doesn't happen from a technology perspective, but innovation requires a lot of transformation in culture for that to happen. And platforms are key. For me, a primary example of platforms from a non-software perspective is a Boeing 737 and the Airbus A320 series of aircrafts. I don't know how many of you people know, but these aircrafts are called as platforms, and these were introduced way back in 1984s and 1985s, and they led to a series of other aircrafts. But these aircrafts are platforms because they allowed things like landing gear innovation. They allowed things like highly efficient engines to be built. They allowed things like better safety equipment to be built, because a standardized system for these aircrafts are the same, but independent contractors could go and evolve better engines, better fuel-efficient engines as an example, better surfaces to make sure that the airplanes can fly efficiently as an example, right? So that's an example of a platform for me. So if you look at what does a data mesh platform look like? Primarily from a data mesh platform perspective, it has multiple layers. We'll talk about 3 primary layers. The first one being the utility plane. And the primary perspective of a utility plane is to expose the infrastructure elements in such a way that it's much more easier to consume, and it can be consumed in a standardized manner. This infrastructure could be things like your compute infrastructure. It could be containerization infrastructure. It could be your databases. It could be your NoSQL databases. Or it could be specific MLOps pipelines that you would need, as an example. But you would not need to worry about the underlying implementation, but you would only rather work at it from an abstracted perspective, because your platform operators are responsible for this plane, and they would ensure that this layer is set up to ensure that it exposes necessary functionality for the next set of layers built above this. The next layer is the data product experience plane. This layer primarily focuses on, again, these are all conceptual layers that we're talking about over here, and these are not actual physical layers which depend upon one another. This is more of a conceptual architecture we're talking about here. The next layer is a data product experience plane. We're talking about this plane which allows teams to create data products and to manage the lifecycle of data products. And teams primarily would be working at this layer, wherein they would talk about creating a data product and not about creating a technology stack. They would not be talking about creating a SQL database, or they would not be talking about creating an MLOps pipeline, or they would not be talking about creating a Kafka cluster, as an example, right? But rather, they would be talking about creating data products and working through in terms of what are the inputs for these data products, what are the outputs for these data products, and what does this data product do, rather than worry about specific technology implementation. And this is where the data product developers primarily work on. And the last one is the data mesh experience plane. And this is where the consumers of the data mesh would primarily use. They would use this to discover data products. They would use this to discover attributes and metadata of this data products. Attributes of this data product could be things like the data quality within this particular data product. It could be attributes in terms of data lineage or data freshness, as an example, or whether this data product contains PII, as an example, right? And that's where the data product consumers would primarily be focused on, rather than the other layers. And each of these layers work closely with each other. If we set up an imaginary data mesh platform, and if we have a team which works on this data mesh platform, what would the experience for a data product developer look like, right? So I have 2 legends. Whatever is in green is primarily what a data product developer would initiate, and the rest would be what a data product, data product platform, the data mesh platform would rather work through. So if a data product developer wants to create a data product, he would define the specification of the data product. He would define the inputs, the outputs, and the various interfaces that this data product would have. And once that is done, and he registers his data product, the data mesh platform would then be responsible for bootstrapping the necessary repository. It would create the necessary pipeline, which would, in this case, be the CI/CD pipeline to build and to deliver and to deploy that particular data product. It would then provision the necessary infrastructure, which is what was defined when the data product developer registered it. It would then the data product developer is responsible for developing the data product and filling in the necessary functionality. Then the platform would build and deploy the data product. It would also perform a scan and a bunch of other areas which would secure the data product. It would then monitor the data product developer is then responsible for monitoring the data product and ensuring that it's performing well in terms of looking at metrics and numbers, and ensuring that it's meeting the necessary customer requirements, and maybe evolve the data product as necessary. And if necessary, the data product experience plane also provides options to retire it. So what does the data product consumer view of this would look like? The data product consumer would be responsible, once a data product is deployed into this data mesh experience plane, the data product consumer would be able to discover data products, would be able to, as I said, look at the metadata of the data products that are available. And once he or she figures out that there is a data product that they would like to use, they would explore it and they would consume it. And that's how we make it easy to ensure that data products can be easily built and consumed. And that's where the concept of a data mesh platform comes into play. So let us look at this from a data science perspective, because that's one of the hardest problems to solve. Traditionally, organizations have had the data scientists sitting right behind the analytical data plane, maybe 3 or 4 layers from where the data domain exists. And if looking at how we would do it in terms of setting up a data mesh experience, primarily, a data scientist works initially by doing exploratory data analysis. They look at data in terms of understanding the trends within this data. They look at patterns within this data, and they figure out what features exist within this data that will allow them to predict or values against a variable that they want to determine. And that's where a data scientist would use a data mesh experience plane to figure out what data products exist out there, which would satisfy the needs that they have in terms of what data they would need. And the data mesh experience plane would also allow them to understand the data exposed by the data product and analyze data within that and to identify patterns. So they would go through those layers, primarily exploring the data, identifying features. Then they would hypothesize and construct a bunch of hypotheses. This could happen through a notebook interface as an example. And then they would sort of measure as to whether the hypothesis works fine. And if they figure out that a particular hypothesis works fine, then they would use the data product experience plane to then create a data model based on what they've identified so far. And then the data mesh platform would ensure that it could be validated, it could be tested, because it would have the necessary pipelines to deploy it, secure it, and also to ensure that it can be delivered through the pipeline. And it will also expose the necessary infrastructure concepts necessary for the data scientists to use. For example, if I want to give you a concrete example, let's assume a data scientist wants to create an abandoned cart model as an example to identify why carts in the e-commerce domain would get abandoned. They would initially look at data that they can expose or data that they can use for training, and that they would primarily get it from the data mesh experience plane. And then they would build a data model, which is primarily an ML model, which they would then expose it through the data product experience plane. And let's assume the data scientist needs an MLOps pipeline such as Kubeflow. And that's where the utility plane comes into play to sort of provision Kubeflow as an example of infrastructure that a data scientist can use to perform his activities. So what do we achieve by doing this? What we've right now done is to sort of decentralize data, and not just data, but also involve a culture of ensuring that data scientists and data folks are not multiple layers away from your domain teams, but rather embed them within your domain teams and make sure the domain teams treat their own data as a product. And what we're also ensuring that the concept of building ML models isn't something that's esoteric and happens behind an analytical data plane, but it's something that can happen within each of these domain teams. And domain teams can start to build their own data models because the data mesh platform makes it much more easier to start off in this area. And going back to how you would move towards from data defense to data offense, and how you would sort of step away from focusing primarily on the basic properties of data into ensuring you can use predictive analysis and a bunch of other amazing factors out there. And this is one way of doing it. And this is where we're talking about data mesh and how a data mesh architecture would enable organizations to empower using the data intelligence and empower culture of innovation within the organization. So that's me. That's a talk about data mesh. And we are exactly on time. Thank you.